Our next topic is scientific notation, and this gives a convenient way to express numbers that are either very big or very small, and it's used a lot in science and engineering. So here's an example of a number in scientific notation. So there's two pieces. There's the power of 10 over here. So here it's 10 to the power 6. And that's multiplied by a number which should be between 1 and 10. So usually a decimal. But to be in scientific notation, this piece has to be between 1 and 10. All right, so this example, it's 7.2 times 10 to the power 6. So it's a kind of a compact way of writing this big number. If you write out this number explicitly, so if you remember multiplying by a power of 10, you're moving the decimal point. That number places to the right. So if you move that decimal point 6 places, you end up, I've added these insignificant zeros to give myself space. You get this number. So it's really, what's that, 7,200,000? So yes, this is a big number. And if this was a bigger number, more zeros, then you just need a higher power of 10 here. Here's an example that turns out to be a very small number, 4.52 times 10 to the power negative 3. And if you remember, we looked at negative powers of 10. So 10 to the power negative 3 really means 1 over 10 to the power 3. So multiplying by 10 to the power negative 3, it's the same as multiplying by 1 over 10 to the power 3. So that's the same as dividing by 10 to the power 3. Yeah, that's confusing. But just remember, if you multiply by a negative power of 10, that moves the decimal point to the left instead of the right. So 4.52 times 10 to the power negative 3. So to calculate this, the decimal point gets moved 3 places to the left. I've added some zeros. So we end up with this number. So this is just written out what this means. So these are equal. And if you had something like 0.000000452, then you just need to change this power. Okay, so this number, it's very close to 0, so it's very small. So this scientific notation, just writing a decimal times a power of 10, it's a good way to write big numbers and small numbers. These are 2 examples again. So just to make sure we understand the idea. This first number, it has to be between 1 and 10. So the smallest it can be is 1, and it has to be strictly less than 10. and then that gets multiplied by a power of 10, and that power can be positive. Here it's a 6, or it could be negative. Here it's negative 3. And that power, it's called the order of magnitude of the number. So it kind of gives a measure of what, the scale, what the basic size of the number. So numbers with positive orders of magnitude are going to be large numbers. Numbers with negative orders of magnitude are going to be small numbers, close to 0. All right, example 1, convert 302.9 into scientific notation. Okay, so we want to make it look more like one of these. Okay, the first thing to do is move the decimal point. Okay, so if we're looking for a number between 1 and 10, where should the decimal point get moved to? Well, if you go this way, you'll get 3029. That's going in the wrong direction. If you move it to here, that's 30.29. That's better, but 30 is not between 1 and 10. But move it 2 places, then you have 3.029. That's 3 is between 1 and 10, so that's the right position. Okay, we've changed the number. If we move the decimal point, we've made it 100 times smaller. So it was close to 300. We've made it close to 3, so that's 100 times smaller. So to kind of counteract that, to have something equal to 302.9, it's this new decimal times 100 times 10 to the power 2. All right, so moving the decimal point 2 places made it 100 times smaller. So to balance that, we have to multiply by 100 to keep it equal. Okay, and the point of all this is, so now this number, this is the original number, but we've written it in scientific notation. A number between 1 and 10 times a power of 10. And you can check these are equal, so if you do multiply by 10 to the power 2, then the decimal point just goes back to where it was originally, between the 2 and the 9. All right, example 2. This is obviously a very small number. Convert this to scientific notation. So the same first step, but where do we want the decimal point to be? You can see we want it to end up between the 1 and the 5. That'll give us 1.5. That's in the right range. So that's 7 places. All right, moving the decimal point 7 places, we've got this number 1.5. That's 10 to the 7 times bigger. So to balance that, we need to divide by 10 to the power 7, and that's the same as multiplying by 10 to the negative 7. So the original decimal, it's equal to, in scientific notation, 1.5 times 10 to the power negative 7. And again, you could check so multiplying by negative power 10, that moves the decimal point to the left. And so these are equal. And again, it's what we're expecting. For big numbers, you're going to have a positive power of 10. So here the order of magnitude is 2. And for small numbers close to 0, the order of magnitude is going to be a negative number. Here it's negative 7. And this is the basic formula. So for scientific notation, it's a number a decimal, times a power of 10. A is between 1 and 10, strictly less than 10. N is called the order of magnitude. For big numbers, n is positive. For small numbers, n is negative. So that's just the main issue. Make sure you have the right sign for that power. Okay, in the book they go into more detail, and we really want. Here are some examples. Yeah, so this one here, 0.0023. So in scientific notation, that's 2.3 times 10 to the negative 3. We had to move the decimal point 3 places. Yeah. The number 1, yeah, you can write 1 in scientific notation. It's just 1.0 times 10 to the 0. We didn't have to move the decimal point, so 10 to the power 0. Yeah, here's a bigger number, 8 million. And so for 8 million, the decimal point is here, and we have to move it 6 places to get it to here. So that's 8 million is 8 times 10 to the 6. And yeah, here kinds of places that shows up. Yeah, so in, say, physics or chemistry, 1 light year. If you convert 1 light year into miles, it's approximately 5.87 times 10 to the 12 miles. All right, so the distance light travels in 1 year is a big number. And if you write the mass of an electron in kilograms, then it's a very small number of kilograms, 9.1 times 10 to the negative 28. And here's that number written out. So this is 9.1 times 10 to the negative 28. And the mass of an electron in kilograms. So yeah, you can see this. It's not really practical to write numbers like this. It's much better to write them in scientific notation. So that's the idea. Okay, so now we get to percents. Okay, these last couple of sections in chapter 4. Yeah, we see percents a lot. Yeah, we've seen them on our credit card bills already. Also sales, yes. So if you see a sale with 30% off, Okay, so this is the percent symbol. Yeah, it looks a bit like division, but it's, well, I guess it is division, division by 100, but yeah, here it means percent, so 30%, it's really a fraction. So whatever the number is here, it's 30, you put it over 100. And that's what it means in Latin. Per means divide, cent means 100. Okay, so it's always 100 on the bottom. So converting a percent into a number, into a fraction, is easy. Example 3, convert these percents to fractions and then simplify. So we want the fractions in lowest terms. Part A, 50%. That means 50 over 100. Okay, so so we're converting this percent into a number. So you put it over 100, and then you can drop the percent symbol. Now it's just a regular fraction. And we can certainly simplify this. The greatest common factor is 50 between the top and the bottom. So divide out by the 50, you get 1 over 2. All right, so you probably knew that already. So 50% is 1/2, 1 over 2. 100%, that's 100 over 100. That's 1, so that's the whole thing. 6%, that's a small percent. As a fraction, that's 6 over 100. And that simplifies a little bit. There's 2's in common. So if you cancel the 2's, it's 3 over 50. Percents, they can be bigger than 100. Here we have 260%. So that's 260 over 100. Yeah, cancel 10's, cancel 2's. That's 13 over 5. So yeah, so any percents that are 100 or higher, you'll end up with an improper fraction. All right, so percents, they're just fractions where the bottom number is 100. So they're so very specific, but also very useful. And now if you divide a number by 100, that's 10 to the 2. We know how that works. That means you're moving the decimal point 2 places to the left. So it's even easier to convert percents to decimals. Yeah, these examples were all whole numbers. And so for 50, the decimal point starts here. Move it 2 places to the left to convert this percent to a decimal. So it ends up here, and you can add an insignificant 0. So 50% as a decimal is 0.5. 100% as a decimal is 1. 6% is 0.06. And 260, if you move the decimal point 2 places to the left, you get 2.6. So 260% is 2.6 as a decimal, Again, as a fraction, it would be 260 over 100, or 13 over 5 simplified. All right, so yeah, I guess it gets confusing. So just looking at 1/2, for example, 1/2, here it is as a fraction. As a percent, it's 50%. Again, as a fraction, you could also write it 50 over 100. And as a decimal, it's 0.5. Okay, so yeah, so in this section, yeah, we're just getting used to switching between these three different representations. So percents, decimals, and fractions. It's all the same number, but just different kind of useful ways to write that number. All right, so if I give you a percent, well, it's easy to convert it to a fraction. Just put the number over 100, and then you get a fraction, so then there's no need for the percent symbol. Okay, so to convert a percent to a fraction, just put it over 100, and then maybe look to simplify that fraction. To convert a percent to a decimal, well, if you're dividing by 100, that moves the decimal point 2 places to the left, so 13% becomes 0.13. All right, so like in the scientific notation, converting percents to decimals, you're really just moving the decimal point. Decimals to percents, you're just going the other way. So to convert 0.13, this decimal to a percent, you have to go backwards. So move the decimal point 2 places to the right to get 13. So that's 13%. So really, yeah, so to go from a decimal to a percent, you're really multiplying by 100. 0.13 becomes 13%. And we looked at this in earlier in the chapter. So to convert decimals to fractions, you just look at the number of places. So here we have 2 places. So this is 13 over 100. If it was 0.134, that would be 3 places. So it would be 134 over 1,000. Okay, so starting with a percent, you could convert it to a fraction or a decimal. Starting with a decimal, you can convert it to a percent or a fraction. So what about the last case, starting with a fraction? So how do you convert a fraction to a decimal or a percent? And so first we'll look at converting a fraction to a decimal. Well, the way to do that is just to do the division like we were doing in the previous sections. So 1/5 means 1 divided by 5. Okay, so here's the 1. We're dividing by the 5. And yeah, 5 goes into 1 0 times, so we need to turn this 1 into, say, a 1.0 or a 1.00 into a decimal. And we're dividing by a whole number so that decimal points line up. Okay, so this is how we're setting it up. Okay, if 5 goes into 1 0 times, but 5 goes into 10 2 times. Put the 2 above the 0 here. 2 times 5 is 10, subtract, you get 0. So 5 goes into 1 exactly 0.2 times. So 1/5 as a decimal is 0.2. Okay, now we can, just like we did over here, now we can convert that decimal to a percent. Move the decimal point 2 places to the right. So 0.2 is 20%. Okay, so yeah, you can convert any fraction to a percent. Just first convert it to a decimal, and then move the decimal point to 2 places. So this is the plan. Okay, example 5, convert 3/7 to a percent, rounded to the nearest tenth of a percent. All right, so we have a fraction, so we're going to use this plan. First, convert it to a decimal. All right, so it's 3.0 divided by 7, and the decimal points line up because we're dividing by a whole number. Okay, so at the start, yeah, we don't know how many zeros we need. So yeah, for this question, yeah, it turns out we need 4 zeros, but let's see. So if we start the calculation, yes, 7 goes into 3 0 times, but 7 goes into 30 4 times, and the 4 goes here. So it's 7 goes into 30 4 times. Okay, the number of times is always lines up like this. 4 times 7 is 28. Subtract that from 30, you get 2. Then bring down the 0. 7 goes into 20 2 times. That's 14. Subtract that, you get 6. Okay, so you can keep going. So here we've found 4 places. But yeah, we don't have a 0 remainder, so that we could get more places. But so far we have 3 over 7 is equal to 0.4285. So as a percent, okay, we move the decimal point 2 places. It's 42.85%. Okay, there could be more digits here. But the question was to round the answer to the nearest tenth of a percent. Okay, so here's the percent. So here are the ones, here are the tenths, here are the hundredths. So this 8 is in the tenth of a percent place, so that's the rounding place. Okay, then check the next digit to the right. That's a 5. That's in the range 5 to 9. So that tells us we have to increase that 8 to a 9. Okay, if it was 42.83, then we'd leave the 8 as it is, but since it's 5 or higher, this 8 becomes a 9, and then everything else becomes a 0. And these are insignificant, so we can drop those zeros. All right, so rounded to the nearest tenth of a percent, it's 42.9%. Okay, and yeah, now you can see why we had to go as far as the 5 here. 4 places. It's so that we had the digit to the right of the rounding place. So if we'd have stopped at the 8, then we'd need one more to get the rounding right. Right, yeah, so that was a complicated question. Okay, so again, we were converting a fraction, so yeah, 3/7. It's kind of an awkward fraction. It's maybe more useful to think of it as 42.9. Okay, more examples here. 97%. As a fraction, it's 97 over 100. And as a decimal, it's 0.97. Okay, so you can go from decimals to percents, or percents to decimals. You're just moving the decimal point 2 places. Okay, yeah, these examples, 10%, that's 0.1 as a decimal, and 1 over 10 as a fraction. Yeah, it's really 10 over 100, which simplifies to 1 over 10. 20%, that's equal to 0.2 as a decimal, and as a fraction, 20 over 100 simplifies to 1 over 5. 50% we saw. Convert 1/4 to a decimal. So like we've seen, yeah, we just do the division. So here we're replacing the 1 by 1.00 and divide by 4. So 4 goes into 1 0 times, 4 goes into 10 2 times, put the 2 above that first 0. 2 times 4 is 8. Subtract, bring down the 0. 4 goes into 25 times evenly. So 1/4, it's 0.25. And that's 25%. One over 40, same deal. Divide 1.0 by 40. So if you do the division, yeah, you get 0.025. And so that's the decimal answer, and as a percent, that's 2.5%. All right, so yeah, this example is just 10 times smaller than this example. All right, then, so an application of percents is to, getting percents of numbers, or So yeah, in this section, fractional parts of numbers. So suppose a coat sells for $40. If it's in this sale we mentioned, 30% off. So what is the reduction? So what is 30% of 40? So we've seen this before. Whenever you see of, what is the operation? Yeah, it always means multiplication. So we need 30% times 40. Yeah, the problem is 30%, it's not a number. So first you have to convert it to a number, either a decimal or a fraction. And so a simple way to do it is, write it as a fraction here. So 30% means 30 over 100. And we're multiplying that by 40. So two fractions here, 40 over 1. Remember, multiply straight across, so we get 1200 over 100, and that's 12. Yeah, doing it as a decimal, it would be 0.3 times 40. If you remember multiplying decimals, you'll get the same answer, 12. So the code is $12? No, so that's the reduction. So the price goes down by 30%, down by $12. So the sale price of the coat is 28. So 40 minus 12 is 28. Example 6, how about 6% of 90? All right, so two things. Again, this of means we're multiplying, and also this percent, we have to convert it to a number. So as a number, it's as a fraction, 6 over 100. So 6 over 100 times 90 over 1. And then just multiplying straight across. We could be pre-canceling here, but just multiplying straight across, that's 540 over 100. So maybe this is best as a decimal. So this is 540. So if you divide by 100, the decimal point ends up here. So 5.4. All right, so 6% of 90 is 5.4. Okay, how about compute 5/3 of 120? All right, so this is a fraction part of a number. And we just have this fraction, 5/3 times 120 over 1. Okay, this time I am going to pre-cancel. 120 is 3 times 40, so I've got a 3 on the top and a 3 on the bottom. Those cancel. We're left with 5 times 40, that's 200 over 1, so that's just 200. So 5/3 of 120 is 200. You could have just, so without pre-canceling, it's, what's that, 600 over 3? Still 200. Okay, here's a more complicated one. Example 8. What is 9.2% of 4.7? All right, so here we have a decimal. We also have a percent that's a decimal. So for this question, it makes sense to just make this percent, convert this percent into a decimal. Okay, so the decimal point gets moved 2 places to the left. So 9.2% as a decimal, it's 0.092. All right, so remember converting percents to decimals. Yeah, you just move the decimal point 2 places to the left. Okay, yeah, I know it's confusing, left and right. All right, so we're really multiplying 4.7 by this number, 0.092. And then now we're just multiplying decimals like we did earlier in the chapter. How does that work? Well, you count the number of places. So here we have 3 places, here we have 1 place. So altogether 4 places. And then multiply 92 by 47. You'll get 4,324, and then give it 4 places. All right, so that's the answer. 9.2% of 4.7 is 0.4324. And it does make sense. So this is close to 10%. 10% is 1/10. That would be 0.47. So the answer is the right size. All right, so just remember getting percents of numbers, convert the percent into a fraction or a decimal, and then just multiply the 2 numbers. Yeah, here are all the different ways to get 1/4 of a number. 1/4 of 90, that's the same as saying 0.25 of 90 or 25% of 90. 22.5. This example, find 125% of 500. So first convert 125% to a decimal, that's 1.25, and then multiply 1.25 times 500. Yeah, if you do that, it's 625. So yeah, if you get a percent of a number, if the percent's bigger than 100, then you're going to get something bigger. So 625 is bigger than 500. Yeah, it's 25% bigger. Okay, how about this one last example? Kind of a word problem. Josh spends 2/5 of his income on rent. If he earns $1,250 per month, how much does he have left over after paying his rent? Yeah, different ways to do this. So yeah, if he spends 2/5 of his income on rent, then what's left over is going to be 3/5, right? So 3/5 of 1,250. So it's 3/5 times 1250 over 1. And here you can cancel 5s. So that's 3/1 times 250 over 1. That's 750. All right, so that's what's left over from his income. Okay, so again, fraction parts of numbers, yeah, you're just multiplying either decimals or fractions. And if you're multiplying fractions, then yeah, it's good to remember pre-canceling just to make the numbers smaller. All right, so that's it for chapter 4.